add two numbers. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the zero itself. For example, we have 243, 564, which represent 342 and 465, and we add them together, which is 807. But the output should still keep in the reverse order, so it will be 708. If the two linked lists is 0 and 0, then we return 0. If it's have some carry in the end, then we also need to add a carry. In this case, this will be the 1. For this question, I'm going to use an iterative approach. I'm going to iterate through each single node for both linked lists, and then I will add those two values together, and then I will calculate the current digit and then the carry value, and then I will keep adding to the new linked list. At the end, I will return that linked list. So let's start coding. First, I'm gonna create a new list node called dummy. I will initialize to -1, and then I will have another one called curl, which will be the head of our output linked list. I will initially point to dummy, and then because we are keep updating current position, we need a way to remember where our head is, so that's why we initialize the current to the dummy. Next, I will create a new list node called P1. The P1 will actually point to the L1, and then another one called P2 will point to the L2. Those are the two pointers to help us keep track of our current node. And then I will have an integer called carry. I will initialize to 0, and then I'll have while loop. So as long as P1 or P2 is not equal to now, that means we didn't reach the end of both linked lists, then we keep the iteration. So well, P1 is not equal to now, or P2 not equal to now, we keep the iteration going. Inside this, I will have first get the value, so I will say v1 equal to, I will use the ternary operator here, so I will check if the P1 is not equal to now. That's true, then there is a value, so I will set the v1 equal to p1 dot val. Otherwise, it's P1 is now, then we set it to 0. Similar logic we do for v2. After we get those two values, we can calculate the sum, which will be v1 plus v2 plus carry. And then we can also calculate the current digit. Current digit will be some integer divided by 10. And then I will have another one. I will also update the carry. Carry will be some modulo by 10. Here I will explain how it works. For example, we have 9 plus 9. As we can see, the result will be 18. So how it works? So first, when we have 9 and 9, we add them together, and then sum will be 18. So the digits of the will be 18 divided by 10. So it will be sorry. So for example, let's say this example we have 2 plus 5, which is 7. So here the 7 we don't have any carry, so we oh sorry, actually the digit is modular and the carry is integer division. So here we have 7, so 7 modular by 10 is still 7, so we have the 7 here. And then carry, we have 7 integer divided by 10, which is 0, so we don't have any carry, which is true. Here we have 4 plus 6, which is 10, so 10 modular by 10 is 0, so we have 0 as digits, which is correct, and 10 integer divided by 10 is 1, so we have carry to the next by 1, which is correct. That's why this is how it works. And then after that we can start append the node. So current next will be equal to new list node, and then we have the digit as a value. Then we update the current node, so current equal current.next. After we append the node, we also want to update our P1 and P2 position to the next. So first we check, we only update them if they are not equal to now. So similar logic, if P2 is not equal to now, we update P2. And then after the while loop, if there is carry, so if carry is greater than 0, that means there carry is left. We can just say current.next equal new list node, and then we use the carry as the new digit. And then after that we can return dummy.next, which will be the head of our output linked list. And then for the time complexity will be O of max m and n, where m and n are the length of the input linked list. So in the worst case we will iterate through the longer linked list, so that's why we have max mn. And then space complexity will be O of max m n2, because the output linked list will be determined by the longer input linked list. For example, we have 100. We have 101. So 1 is 3 node, 1 is 1 node. Then in that case, the output will be 3 node. That's why space is also max mn. Next, let's test this code out. Looks like we passed the test.